Warrior, very glad you're here. It's tough to get more cutting edge than this. We're talking about drones, drone attacks, and AI and the combination between. A lot of attention about commercial drone technology, what's going on in the Middle East and Ukraine. We are joined now by one of the cutting edge innovators, Mr. Aviv Shapira. He is the CEO of an Israeli based company called Xtend that's doing some cutting edge work with the Pentagon. Sir, thanks for your time. Appreciate talking to you. Let's talk about your technology.
Same here. Thank you for having me. I'd love to talk about everything. Where do we start?
Well, sure. The Scorpio, it's this deal that I understand you have with the Irregular Warfare Technical Support Division of the Pentagon, working with SOCOM to help these innovations get to the war zone per se. Tell us about the Scorpio and what makes it different than existing drones.
Yeah. So first of all, everything in Xtend is based on a cutting edge operating system. Okay, it's called XOS. The operating system basically allows anyone without any prior knowledge, any training to actually control a swarm of drones, different vehicles, ground, air, different types of robots. And you can actually do that from anywhere in the world. And our secret sauce is that we actually train AI pilots to fly alongside real pilots in this swarm of what we call an army of AI robots. I know it sounds a bit science fiction, but this is what we are doing, and this is how we are winning the war.
Excellent. Well, let's talk about that because the cutting edge of AI looks very much at real-time analytics and bouncing things off of a database, making those determinations and networking the data in real time. Does your swarm work like that, and how are the algorithms configured to enable in-flight coordination?
So you're completely right. Until now, AI was only used to give the end user the feedback on this is a vehicle, this is a car, making its mission more effective. This is the first time that actually AI is flying robots, flying drones, controlling robots in war alongside people. So I'll give you an example. So let's say I have 3 drones in front of me, and I'm telling drone number 1, you scan the first building. Drone number 2, stay above me and watch my back. Drone number 3, come on, we're going inside the building. That's it. This is what we're doing. And again, it's all about AI teammates, or how can you use AI to actually help you support your mission and allow you to actually be better at what you do.
Well, that's excellent. Cutting edge collaborative AI. It calls to mind the Air Force's Golden Horde, where munitions themselves are sharing data in flight to adjust to new information. Sounds like this does that in a collaborative way or a collective way, which is quite significant. Let's talk about the weaponization, because from what I understand, this can be armed with munitions and very specifically and directly identify and destroy targets and be recoverable. That's quite significant.
So I would say the big difference is jumping from computer vision to AI. And what does that mean? So, until now, you select a pixel and the drone would actually hit that pixel. When it comes to AI, you can say, let me select a target. So, I select a vehicle. The drone knows this is a vehicle and is going to chase him until he hits that vehicle. That's the big difference. And to your previous comment about persistent strike indoor outdoor, that's a US-based program with SOCOM to deliver hundreds of systems to the end users. And that's the first and currently the only quadcopter drone in the US government that has a safety fuse approval to be used as a loitering munition platform. It only took us about 2.5 years to get there.
Sure. Well, there's a lot of discussion about loitering drones being used to destroy tanks in Ukraine, obviously tactically useful in Hamas and the Middle East as well. My question is, tactically speaking, what does this involve and what does this mean? This means an AI-enabled small form factor drone can transit from outside a building to finding that opening, going in, finding the target, verifying that target, and destroying it autonomously with human in the loop on lethal choice.
So you just crossed what we call the ethical barrier of AI. Without human supervision, AI does not destroy targets. It's not ethical, and it's not what we do. I don't think anyone would do it on the western side of this planet. But what we can do is get to that threat, get to that person, and then ask the human supervisor, hey, is this the valid target? Can I move forward? Can I destroy? But searching for that target, getting to that building, getting inside the building, even breaching the building is done by AI. And I have to tell you that AI is much more ethical. So, if you're homing in on a target and suddenly, a person came into the picture, into the frame, the system with the board. This is very, very important, as opposed to computer vision, where it's like dead on the target. AI actually allows you to understand what are you doing. So I'm trying to hit a car or a tank. Someone goes into the video. I'm stopping. This is not my mission. Hold it. No, not anymore.
Well, that's excellent. The idea of a built-in stop mechanism is fantastic. And of course, it sounds like it's very aligned with the Pentagon's doctrine of human in the loop when it comes to the use of lethal force. Part of why the prevailing consensus is to look at both. The optimal approach is human consciousness and AI working in tandem. And with this computer speed and processing speed, the decision-making process can be exponentially expedited to close that curve and truncate sensor to shooter and pair sensor and shooters.
Yeah. So, if you can think about it, one of the things that we're doing, so if you are a soldier on the ground and you're heavily dependent on an Apache helicopter, a UAV in the sky, or, our artillery to come and help you out, we actually giving our end users the ability to own the power of the Air Force in their hands. So what does that mean? So if I'm a sniper or if I'm a gunman and I point it at the relevant targets, as long as I'm connected to the C2, to the ATAC system, I can actually deploy now a drone, 2 drones, 5 drones at my target. So this is exactly what you talk about, human machine integration, HMI. Everyone is talking about it. We're actually doing it, but we're doing it in the right steps, not to try to move too far away. So we actually break what we call the ethical barriers of what AI can do and what it cannot do.
Roger, that totally understood. And it's something to emphasize anytime you talk about AI because of how quickly the technology is maturing, human in the loop, even if the technology exists for an autonomous vehicle to make an attack, that there's human verification, bounces off a database, that there are protocols in place, ethical parameters as well. One of the things you talked about, and it inspires 2 questions. One is networking and the extent to which these bodies in the air can network with one another to share targeting information. How is that progressing, and how can that be hardened? Because it calls up this second question about hardening AI and some of the built-in challenges. That'll be my last question.
So, it's every drone is a node on the network together with the human. So imagine like, two operators with 5 drones. There are 7 nodes on the network. They can talk with one another. This is basic Ethernet protocol. If you lose the human, they would still talk to one another because they're on the same network. But you mentioned something important that I want to talk about. So it's not only about attacking targets and attacking tanks, what you see. It's sometimes, you need to send a drone to go and look for something. Fly to a point XYZ and count how many cars do you see, come back home, send me a report. I don't even need to see the video. So this is where we are getting at. So it's this evolution where we're now finally able to utilize drones and robots in a much, much more extensive way using AI.
Well, that's excellent. And we have to talk about zero trust and the reliability. One of the things I know the US Army is doing, and I'm sure they're not alone with lots of industry partners, is hardening AI, because the core challenge is when you bounce something off a database that isn't recognized or previously there, you hear that AI is only as effective as its database tag data. Now, there's real-time analytics going on, looking at holistic variables and determining context to discern key identifications. But what's happening with efforts to harden this against enemy intrusion, jamming, or potentially find a false positive?
There's an interesting movie online where people in San Francisco have this stop sign, on their shirt, and they're just opening their shirt in front of autonomous cars and they stop. So, AI is not that smart yet. I think it will get there. We all understand it will get there. And I would say that, the way that we are actually training our systems is using simulators. We're not tagging pictures. These days were like three years ago. So, overnight we can tag like 10 million pictures, and that makes the system much more bulletproof. But it's also failing. This is why this human machine collaboration is very important to this day. Middle of 2000.